So in this video, we're going to be learning about arithmetic series and also quadratic patterns. I'm going to teach you, they're asking advanced questions here about the arithmetic series and quadratic patterns. It's not traditional questions, right? So please tune in because it's a very important question. So we're still doing grade 12, mathematics paper 1, November 2024. We've done a couple of questions and now we're in question 2. So we've been studying from the last question till question 1. So now in question 2, please check out other videos. Let's go to 2.1. So 2.1 says that the first term of the arithmetic series is 7. So what do we know? We know the first term, and the first term is equal to a, which is equal to 7. And we're told this is an arithmetic series. An arithmetic series, basically, the equation is Tn is equal to a plus n minus 1 times d, where a is equal to a first term, right? And d is basically a difference between the first term and the second term, or the third term and the second term. So that's basically what we know from the first statement, right? The first term of the arithmetic series is 7. The common difference of this series is 5. Now again, they're telling us that the common difference, d, is equal to 5. D is equal to T2 minus T1, or it can be equal to T3 minus T2 is equal to 5. And then they say n series of contains 20 terms. So we know that n is equal to 20. We have 20 terms. So what does that mean? It means that you have series that move from T1, T2, T3 until 20. That's what they're telling us. And in 2.1.1, they say calculate the sum of these series. So how do you do that? The sum of the series. Remember, we are talking about an arithmetic series. So with an arithmetic series, you are fortunately enough given an information sheet. So we're using, because in arithmetic series, we're using this formula or this formula. So if we're talking about the total of your series, we are going to be using this formula. If they ask you what is the total or the sum of your series, this is the formula that you're going to be using. So that's the formula we are using. Sn is equal to n over 2. Was it 2a or a? Yeah, it's 2a. 2a plus n minus 1 times d. Now, the question says calculate the sum of these series. Again, we know it is 20 series. So you're just calculating the sum of the series. So S20 is equal to, let me just take this off, that's because that's not equal. S20 is equal to n is 20 over 2. What is A? A, we've been told, is 7, okay, plus 20 minus 1. What is D? D is 5. We know that. And you need just to punch this in your calculator and you get your answer. And the answer that you should be getting is 1090. That's your answer. Check out in your calculator, just punch it the way it is, you get your answer 1090. All right. Now let's go to 2.1.2. Now it's getting interesting, okay? They're saying that the original arithmetic series is expected to be 75 terms. Now, they're saying now you have extended, to 75 terms, from 20 to 75 terms. And the sum of these 75 terms is 14,400. Using similar notation, write down the equation of the sum of the terms added to the original series. So what they're saying to us is this. They're saying, listen, you have the first term, the first 20 terms, right? Let's say n's got to 1 to 20. So you're calculating the total, the sum of those terms, right? We know that is basically this, which is the sum of the first 20 terms. And now they're extending this series into 75. So from 21 to 75. Okay, let's call this Tn. And they say the total of all these series is equal to 14,400. 14,400. Right. What do we know? Of course, we know this is equal to that, right? We've calculated on our previous video, on our previous question. So this is going to be 1090, and again we have this is 14,400, okay, and 2175. Now the question is, they're saying, of course, use sigma notation. That's what you're using to write the equation for the sum of the first term of the original. So they want us to solve basically for this. So basically you have the sum of this and 21 to 75 is equal to 14,400 minus 1090. So if you punch this in your calculator, what do you get? So let me see. Got 14,400 minus 1090. I'm getting 13,310. Okay. Now you have the sum of this 13,310 from n is 21 to 75. Now we need to find what is Tn. Okay. So to find Tn, Tn again is equal to what? A plus n1 times d. And now this is easier because we know that we are given A as 7, if you remember, 7. And n, it's, of course, we don't need to find that. And we know that d is equal to 5, as we've been given as 5. So Tn is equal to 7. Remove the brackets, going to be 5n minus 5. So Tn is equal to 5n, 7 minus 5, that is positive 2. So Tn is equal to 5n plus 2. And then just plug that into your sigma notification. It's equal to 13,310 and 21 to 75. Boom. That's how you represent it. That's how you answer this question. It's a very nice question. Let me know if you get it. Let me know if you're following through as well. And we're gonna go now into 2.2. And 2.2, we basically talking very advanced quadratic pattern, right? This is not something that you will get in your textbook. So pay attention. You are given that you are being told that the sequence of the first difference of the quadratic pattern is 1, 3, and 5. Okay. I'm going to remove all of this because we're not going to need it. I'm going to need the space here. And I'm going to just come up here, and they say to us, you have the sequence of the first difference, right? So the sequence of the first difference, so you have T1, say T2, T3, okay? And we know that the first, they were told that the first difference, or the sequence of the first difference is 1, okay? 3, so that, you know what I mean? If this is T4, so this is going to be 5. Of course, that last difference is 2, okay? So we are being told this particularly. Now they say if T99 is this quadratic pattern, if T99 of this quadratic pattern is 9,632, calculate the T value of 98. Now, let's look at this like this way, right? They're saying that if we know T99, what is T98? That's basically what they're saying. So how will you get this, right? So look at this. If you know T3, you can able to find what? T2. If you know T2, you can able to find T1, right? Because T1 is equal to T2 minus 1, which is equal to T1, right? T2 minus this differential, let's call it this different D1, let's say D2, D3, right? So T2 minus D1 is equal to T1. T3 minus D2 will be equal to T2. So what I'm saying is T2, if you have to find T1, you'll be say the second term minus 1, and let's call 1 as like the first difference, the first term of the first difference, D1. So if we have to generalize this for all the terms, Tn could be written as T n plus 1 because it is 2, n plus 1 minus dn. Now, what are we saying? We're saying T98 could be written as T99 minus dn. And luckily, we know T99 as this value. However, we don't know dn. But we can find dn because dn, we already have a pattern of the first difference, right? We already have this is d1, d2, d3, right? We don't know dn, and again dn in this case is, if we come back here, it's 98, right? 98. So we need to find what is d98. That's what we're looking for. Okay, so what we can do, we can essentially use this as a arithmetic series or sequence. Okay, and we know that an arithmetic sequence is Tn is equal to a plus n minus 1 times d. And of course, we know that the difference here is equal to 2 because 3 minus 1 is 2 and 5 minus 3 is 2. So this is equal to 2 and a is equal to 1. So Tn is equal to 1 plus n minus 1 times 2. Of course, if you solve for this is going to be Tn is equal to, maybe zooming up like this, Tn is equal to 1 plus 2n minus minus 2, which could be written as 2n minus 1. Is it? Yes, 2n minus 1. This is 1, 2, minus 2. Yes, 2n minus 1. Okay, great. So that's what you're having as a term of differences. Okay, then we can find d98, right? I mean, supposedly we call this, instead of t, let's just call it, because let's continue our notation really, dn, dn, dn. And what we're looking for, we're looking for d98. So d98 is equal to 2 times 98 minus 1. D98. So let's type this in your calculator. What do we have? So 2 times 98 minus 1. I'm getting 195. Let me know if you're also getting 195. So what are we getting here? We're saying T99 minus D98 will give you a T98, right? So to get 98 to be T99 minus D98. And T98, and we know what is T99. T99 is given as 9,632. So this is 9,632. And D98, we found it up here as 195. So T98 is equal to, I see why I said this is a very advanced arithmetic series or sequence. So, so 9,632 minus 195, you have 9,437. So that is your T98, and that's what they're asking you from here. And that's why this is like actually 3 marks, but I mean they were stingy with their marks, but you will get a mark for essentially getting a D, which is that basically getting doing this, and you get a mark of course for the final answer, and you get a mark for working out the term of the first difference. Now I want us to go to 2.2.2 because it get a little bit complex, but easier if you understand like the basics of quadratic patterns, and that's what I'm going to be giving to you, right? So let's go on. 2.2 says, if it's further given that the third term of the quadratic pattern is 32. Okay, so now let's come back. So I'm going to rub this off. and understand what they're saying. So they have T1, T2, and they say the T3 is given as 32. Okay, that's what they're telling us. Determine the general term of the quadratic pattern. Of course, quadratic pattern general term is equal to Tn is equal to an squared plus bn plus c. So we need to find what is a from b from c. Okay, we need to find this. And with our note, what do we know? Okay, from the previous understanding, we know that the first term of the first difference is 1, the second term of the first difference is 3. So we know that this is equal to 1, this is equal to 3, and it's equal to 2. And some note, we know that 2a is equal to 2. This is some note. Let me write in green just to highlight that I'm saying these are notes. And another note is we know that 3a plus b is equal to this one here. Another note is we know a plus b plus c is equal to t1. Okay, so that's what we know. Now we can use all of this information to be able to find a and b and c, and then voila, we have our general term. How do we do this? So we know 2a is equal to 2, of course, divided by a on both sides, so your a is equal to 1. Right, we found a. B, we have 3a plus b is equal to 1, and we know a was just 1, so 3 times 1 is 3, plus b is equal to 1, so b is equal to 1 minus 3, which is minus 2. Now I need to find c. You see how easy it gets, right? So you have a plus c plus a plus b plus c is equal to t1. Now we don't know what is t1 yet, but we know what is t3. But we can able to find, because we know 1 in the first sequence, the first difference sequence. So we can able to find t2 and find t1, right? From this. Because what do we know? Of course, we know that t2 is equal to what? 32 minus 3, right? And 32 minus 3, that is 29, right? Yes, 29. And t1 is equal to, now t2 is 29, so it's going to be t1 is going to be 29 minus 1, right? This one here, which is equal to 28. So that's our t1. Now we can then substitute our t1 here. We know a is 1, we know b is minus 2, and we know t1 is 28. So 1 minus 2 is just basically minus 1 plus c is equal to 28. Therefore, c is equal to 29. And now we have a, b, and c. Therefore, if we come here, Tn is equal to a is 1, so we have n squared. B is minus 2, n, and c is equal to 29. And that's your answer. That's your answer. And this is how you get your 5 marks. Is it 5 marks? Yeah, 5 marks. So you'll definitely get a mark for getting an A, getting a B, getting a C. That's 3 marks. And get a mark, essentially half mark for getting T1 and T2. So this is half mark, and this is another half mark. And then finally, you get a mark for writing a general term of a quadratic sequence. This has been a really lovely question. Question 2 has been really lovely. I don't know how many questions I've done in arithmetic and quadratic. They have been very boring questions, but this is one of the most exciting questions I've ever done in arithmetic and quadratic. I hope you enjoyed as I have, and I'm going to see you in the next video. Don't forget to share this with your friend. If you found value, give me a like, give me a subscribe, and I'll see you in the next video. In the next video, we're doing question 11. So pause this, take a screenshot, and I'll see you